Welcome to the shop. I'm continuing to make parts for NQALHA Production Run 4, and I'm almost finished. This is going to be a collection of some kind of odds and ends, some little pieces, and it will probably be not quite the last, but close to the last of the machining videos before I get down to electronic assembly and final assembly of the NQALHA. I'm going to start out making controller insulators, and these are made out of wood. And the wood that I'm using is, see if you can see here, this is a special kind of plywood called, what originally called Finnish birch from Finland, but then when originally the Soviet Union and now whatever, I'm not even sure what countries, but it's marketed as Baltic birch. It's a solid birch plywood that has a lot of thin layers. Commercial softwood plywood has fewer layers for the thickness, and so this has more layers of better quality wood and no internal voids because every internal ply is plugged to remove the defects. The controller insulator was added in version 2.2, and the reason for it is that on the left-hand side of the handle is the controller box, the aluminum controller box, and the controller has electronics in it, motor drivers, and the motor drivers generate heat, and the heat is conducted into the box because of the way it's designed. The box acts as a heat sink for the motor drivers to keep them from overheating, and so the box gets hot. And it's not really a big problem, but since I'm constantly trying to make minor improvements and just fix minor annoyances, I mean, it's not like you'll get seriously burned if you touch it, but it's always nice to isolate hands from hot things. So I added this additional part, the controller insulator, and changed the material of the lever on the handle, changed the material from aluminum to epoxy glass, which is really strong and insulates really well. So in this operation, it's also done in two operations, but I'm not going to set up the left and right vise and do a combo tool path because it's actually faster just to do the whole thing in work offset 1 because of the time it takes to do a tool change. So I've got the machine set up, I've got the tools loaded. If anybody is interested in seeing how the machine setup is done, how the Heimer indicator is used to find 0, how the electronic tool setter is used to find Z0. It's in the earlier videos, the first and second and some of the following ones. But for today, everything is set up. I'm going to put the little piece of wood in the vise. Put on my safety glasses, which not only are protective, but they're also prescription, so I can actually see the screen. So, known trusted tool path, should work just fine, but as always, single block mode, finger on the stop button, looking sane so far, stopping in the right place, no coolant, full machine speed, 5140 RPM, 10 inches per minute, no peck necessary in wood. And it looks like things are going perfectly well. This part will be finished with conversion varnish, clear conversion varnish, the same that I put on the handles. Stopping in the right place, stopping, feeding, single hole, all is well. The catalyzed conversion varnish, the two-part finish, works really, really well, and I use it not only for the NQALHA wood parts, but for my my glass wood and metal sculptures as well. And there's the slot for the lever, and that completes the first operation. After I run all these, I put them on a tooling plate and machine the outside perimeter. So it's not a very interesting part, but hey, just for sake of completeness, I'm trying to show not quite all of the operations. There's a few of the operations where it's just cutting rod stock to length on the chop saw with no further machining. And why bother? You've seen me use the chop saw. So anyway, gonna run all the first operations and turn off the camera and then come back, run the second operation, and then I've got a couple other little parts to do, and boy, it's getting so close to completion now. First operation drilling is complete, and I thought I'd take a moment here to talk about the plywood that I use. In the 70s, I had a woodworking shop, and some of my customers demanded the best plywood available in the world. And at that time, it was finished birch. And when I say finish, I don't mean like the quality of the surface, you know, rough versus finish. I mean made in Finland. And this stuff was so obscure that no lumber yards had it, not even the good lumber yards. I had to go long distances to specialized companies and pay outrageously high prices to get this stuff. And then one day, my local lumber yard said, hey, we have a new product, Baltic birch from the USSR. And the good news, they had a lot of it, and it was really inexpensive. It was less than half the price. The bad news, it was really inconsistent. The sheets were odd sizes, almost never the same. Thicknesses were all over the map. Some of it was warped, some of it delaminated. I used to make jokes about, oh, Comrade Ivan must have hit the vodka last night before making this. And anyway, little bit by little bit, the quality got better. I actually had the side panel with printing on it from one of the crates that the material came in that said made in USSR on the wall in my manufacturing company, just as a kind of like somewhere between a joke and a political statement about, what the fuck is wrong with the Cold War? Why can't we all just get along together? And little bit by little bit, the stuff became more mainstream, and now pretty much every woodworking supply, every lumber yard has some of it at least. It's no longer made in the USSR. I don't actually know which of the republics it was made in, but the quality has gotten better, availability has gotten better, and I like the stuff. So I'm going to be doing the second operation, which is milling the periphery. This will be the same outside size and using the same tooling plate as the controller housing. So let me grab, I'm using the 1/2-inch diameter 3-flute aluminum cutter. Wood likes to have the faster surface feet per minute. A wood router typically runs at 20,000 RPM. This thing won't run at 20,000 RPM, but I figure if I use a larger diameter cutter running at the max speed of the machine, which is 5140, that I get decent surface finish, and it seems to work well enough. So, known trusted program, you know the drill. Finger on the stop button, single block mode, stopping in a reasonable place, reasonable, reasonable, reasonable. Doing a climb milling cycle to try to minimize tear out on the wood. And there we have it. So I'm going to run the rest of these, and then, boy, getting close to the end. Got a couple of more little odds and ends to do today, and then a little bit more in the next couple of days, still waiting for the anodizing and plating. And boy, pretty soon I'm going to have units available. So see you later. The next part that I'm going to be making here is a little sheet metal part. And it's a kind of a little oddball. It's a part that goes on the vertical arm that is like bends over and holds the conduit in place. And no, I couldn't find one, a commercially available one that meets my needs, so I make it. This one will be, start out with blanks, just cut by hand with a Sharpie mark and a power shear. Maybe someday, of course, the shop is too small. Even, you know, I can afford a nice sheet metal shear, I just don't have the space to put it, so. And yeah, it's not accurate. It's as accurate as I can do it, but it'll be cleaned up in the next operation. I'm only going to cut one of these on camera because I have 20 of them to make. So in the next operation, I'm going to stack up a bunch of them in this fixture and put it on the Bridgeport and mill all of the perimeters and drill all the holes in one operation. And the result will end up very nice. Then I use this fixture, we can get that in the camera, and this guy does the bending around a correctly turned steel pin. So I'm going to finish the manual cutting and then turn the camera back on for the oh so exciting Bridgeport milling. Bet you can't wait. Little sheet metal parts are very crudely cut to the approximate size, which doesn't matter at all. They go into this fixture kind of thusly and get kind of poked in over to the back screws, which kind of aligns them somewhat. And they're still, I mean, they're all over the place. They're bent, they're not the same size, they're not the same length, but this will all be resolved when the milling process starts. So I'm going to line it up. I've already set the 0 using the Heimer indicator on the Bridgeport. And actually, that would have been backward. Let me just make sure here. One of the nice things about the Bridgeport 2-axis, you can do a kind of a dry run, and Yes, that is looking pretty good. So let's get the piece in position. Jog back out. Get all of my little guys up against the screw. I've got a second set of blanks on the right side to equalize it out. It has to be balanced because the screws are only screwing in the middle, and if this was unbalanced, it would tilt up like that. So and make one last adjustment here. I cut the blanks way oversized. And so it's not necessary to get them to line up perfectly, but so there we go. Nice and tight. There are 10 pieces of 26 gauge steel here. And first thing that I do, and as much as I don't like doing this because tool changing on the Bridgeport is a tiny bit annoying, it really is, this is the way it has to be done. So first operation will be to drill the hole, and I think this one actually is a somewhat looser hole, so and sure enough, lines up with the fixture. Got a little mist coolant going here. Oh, put the quilt shop out of the way. Drill a hole. And gonna just drop a screw in. Helps hold it in place a little bit more. And put this guy away. And looks like my tool path doesn't tell me what my next tool is going to be. So off to the CAD room. This is an older tool path, and my newer tool paths have in the comments in the G code, have the tool information, and this one kind of didn't. So there we go, 5/16, 4 flute, solid carbide. And that is, it's correct, but it's not correct. Yeah, sometimes even the known trusted tool paths, sometimes they have odd things going on. So, gonna do the typical dry run, just the kind of the sanity check. I'm going very conservative here because of two reasons. First of all, it's steel. Second of all, it's a bunch of little pieces of steel that tend to cause trouble as they bend and get caught in the cutter. And I just want to be really careful. This is a slightly dicey setup. It's not being held as perfectly well as I would like. Checking clearance, get my mist coolant going down to 3,000 RPM. Could do it in one pass, but I'm doing it in two passes just to be conservative. It doesn't take that long to run. And it's just better to not bother them up. I can sort of check clearance. Check my depth. And there, we have a very, very nice, this process produces extremely excellent results. Oh, didn't quite get that one far enough. All of the first operations have been completed. So now, and the parts look really, really nice. This surface is really, really nice. So now, going to turn it around on the other side of the fixture. Try to line up the hole. Actually, slightly annoying to try to line up 10 pieces of sheet metal with a little hole. So I'm going to put some of the other parts on the other side just to balance it out. And looks like they're all lined up correctly. I'm going to start the program and do the typical sanity check just to make sure. And yes, it is looking reasonable. And once again, I take it very, very slow. The clamping on this, and actually, That's even slower than I'd like. Let me go over to the CAD system and fix that. Going very slow and very conservative because the clamp is, it's okay, but I don't want to push it. It is steel and it is multiple layers. So let's do the sanity check again. It's going 5 inches per minute, which I could probably bump it up a little, but yeah, that's looking sane. I'm confident. Turn on the mist coolant. Doing it in 2 passes. All is well. Looking good. And there we have it. Looking very nice and successful. So that is what the blanks look like, or actually not blanks anymore, they're parts in progress. They're all cleaned up, they all have nice proper dimensions, they're all excellent little parts. And then the final step will be, after I mill the next set, over to the bending fixture and do the bending. So see you later. The blanks are now, I keep calling them blanks, the second operation on the parts has been completed successfully, and now time to put them on the bending fixture, which, maybe someday. This is a fairly annoying little guy to use. My screw thread is getting boogered after making a lot of these guys, and probably on my to-do list is going to be a better fixture. So there we have the part, the second operation part, in the bending fixture. Then it's as simple as that. And that is the finished part. Not a very exciting part, but, parts are parts. You got to have them all. So unless I think of something else to do today, that probably concludes today's video, and very, very close to concludes the entire manufacturing portion, the machining portion of the project. There's a little bit left, trimming the neoprene rubber on the levers and cutting some stock to size, but machining operations are pretty much complete for the basic NQALHA. I'm probably also going to show making lock collars, which is an accessory that goes with the machine, but I think that'll do it for today. So thanks for watching. It's been fun.